Hi, everybody. We're going to admit, I want to do a problem today from section 2.2, problem number 3. It's kind of interesting. I like it, and we're going to do it right now. So let me share my screen with you. And whoops, let's find the problem. Where'd it go? Here we go. Yes. Okay. So this is from the discrete mathematics, 2.2, problem number 3. How many 8-letter words can be formed from the 26 letters in the alphabet? So see above here, we had a problem. Above here, we had this problem here. How many words can you make out of the letters A, B, C, 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 D, E? And so there was 8 factorial divided by 2 factorial, 3 factorial, which came out to 3360. But now we're doing a different question. The question here is, Question here is, and again, this is straight from the textbook. I just copied and pasted. How many 8-letter words can be formed from the 26 letters of the alphabet? Now, if you notice, the alphabet doesn't repeat letters. The alphabet is just A, B, C, D, E, F, G. I could continue on that. And so you don't have the whole business of dividing by factorials. But it says that there are 2 interpretations. What does it mean, 2 interpretations? Well, to me, what that means is it might mean 8-letter words where there is no repetition of letters in each word. Meaning once I grab an A, then A is gone. So I only have 25 letters left. Once I grab a W, great A and W, it's great root beer, by the way. And now I have these 2. There's only 24 letters left. So that's one way. Or another way I could look at it is I'm allowed to duplicate. I could have A, or M, G, G, B, 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 B. So I have all these possibilities. So let's look at it both ways. So let's answer both. So I'm going to say non-repetition. Let's see, we'll call it, I don't know, case 1. Well, it's not really case 1. It's interpretation 1. Interpretation 1. Which is non-repetition. Is that how you spell? No, it's not how you spell. How do you spell repetition? Oh, there we go. Okay. Well, so again, the first letter is going to be, there are 26 possibilities for the first letter of our word. So we got to start with some letter. Once I pick the first letter, I have 25 letters left to choose. Let's say I pick a J. So I pick a J. Now there's 25 letters left. So I'll pick so I can choose any of those 25 letters. So I pick the J and a K. Just kidding. Get it, JK? Just kidding. And now there's 24 letters left, and this is going to go on. 23, 22, 21. All the way down to what did I say? 8-letter, 1, 2, 3, 4, 5, 6, 7. And now for the 8th letter of our word, there are 19 possibilities. So the answer is just going to be 20 times 26 times 25 times 24 times 23 times 22 times 21 times 20, which what does that equal to? I don't really care that much, but let's just see what it equals. 26 times, oops, that's not what I want. Let's clear this whole thing. Okay, 26 times 25 times 24 times 23 times try that again. Okay, 20. This may take I'm going to pause this because the way I work, it takes like an hour just to get this. No, I don't want to pause the share. I want to pause the video. Pause the video. How How do I pause the video? Should I pause the video? Why can't I see? Usually, oh, here we go. Pause recording. Okay, so 26 times 25 times 24 times 23 times 22 times 21 times 20 times 19. It's 8 different things. That equals, drum roll please. There you go. 62 lot. What is that number? That is 62 million 990,000 900. No, sorry, 62 billion 990,928,000 different words, and that's actually the smaller one because interpretation 2 is actually going to be bigger. Interpretation 2 is going to be a bigger answer, and that's going to be with repetition. In other words, I could have a. So really, for the first number, for the first letter in our word, there could be 26 possibilities. For the next letter, for the second letter in our word, there could be 26 possibilities. For the third letter is 26 possibilities. The fourth letter is 26 possibilities. And this is, as you can see, this is just going to go on. And I have, so this is just going to be 26 to the 8th power, which actually is easier in the calculator. Even though it's a bigger number, it's going to be easier to put in the calculator. 26 to the 8th power. And that's going to be, as you can see, it's a bigger number. It's 208 billion. Let's compare the two numbers there. It's 208 billion 827,064,576. Notice a couple of things. So first of all, notice that this is about 3 times the size, right? 62 times 3 is going to be a little over, more than 3 times the size. That's number one. Notice that also interpretation 1 with the for the top answer ends with all those zeros, and this doesn't end with any zeros. That's actually an interesting phenomenon, which we actually kind of relates to what we did towards the end of the number theory book. We were talking about how many powers of this and that can go into so when you have 26, 25, 24, 23, you have a whole bunch of 5s and 2s in there, which contribute to make those zeros. Whereas here, 26, 26, there are no 5s. But you have a bunch of 2s, but there are no 5s. So that's kind of why that is. Anyway, I digress. That's it. So these are 2 interpretations, 2 different answers, and that is 2.2 number 3 in the applied discrete structure textbook. I hope you all enjoyed it as much as I did. It's been fabulous and thrilling. And that is it. Bye, everybody. Are you sure? Yes.